All right, welcome back, guys. I hope you enjoyed your break. Let's dive in here. We got to learn some quadratics. All right, first off, we need to be solid on our factoring. It's going to be used to solve our quadratics, so go ahead and pause and practice your method. And remember what we're talking about here is if we use the diamond method, you're looking for what will add to your -7 and multiply to the 12, okay? What's going to add to your -7 and multiply to your 12? What are your two magic numbers? And because it's an x squared simple trinomial, where a, what's in front of the x, is 1, then we can just leave it as x and x up front, and our two magic numbers fill in the rest of the binomials. So go ahead and factor number 1, and then do the same thing and factor number 2. All right, so if I'm thinking about this, I'm going to start with what the factors of the 12 are. That's what I want to work with, so I can think of 3 and 4, or 2 and 6. I'm going to try those to begin with, and they need to add to a 7. Now, because the 12 is positive, I know the signs will have to be the same on these guys. And since they're adding to a negative, they must both be negative numbers. That'll make the multiplication cancel, and they'll both add to a negative. So I need 3 and 4. Those are the two numbers that are going to work and add to 7. So it's x minus 3 and x minus 4. All right? We do the same thing on the second problem. I'm looking for the two numbers that are going to multiply to my -16, and they're going to add to my 6. So if I factor that out, I've got a 2 and an 8, I've got a 4, 4. Those are the two off the top of my head. I'll try those. And since it's a -16, I know one of them's got to be negative and one of them positive. So let's look. Since they're mixed signs, they're going to subtract from each other. 4 and 4, if they were opposite signs, would cancel the 0. So it's not that. It must be 2 and 8, which does work out. And since the 6 is a positive number, the bigger number, the 8, also has to be positive, so the good guys win. That makes them -2. Both my binomials will have an x up front, and there you go. X minus 2, x plus 8. I'm betting someone might have a question about what if I had those reversed, Mr. A? And that's totally fine. It doesn't matter. If you happen to write it x plus 8 and x minus 2, it's not going to matter. Multiplication is commutative, meaning the order doesn't matter. And since we're multiplying these two together, you'll get the same answer either way. All right, this is really important. If you don't get this, you should stop right now and go back and watch my trinomial factoring video and work through that, because you need this to finish today's lesson and get this new content. All right. This is just a little bit of review practice, putting this together with our new quadratics understanding. So, just like we did yesterday, go down this list here, do each of these guys. Okay, I'll give you a minute. Go. All right, vertex is connected with your axis of symmetry, so I'll do those together. Right in the middle of my graph, that's the axis of symmetry, meaning that's exactly the same on both sides. That graph's identical on both sides. So my axis, or my axis of symmetry is the line that's right there crossing the x-axis. And where does it cross it? It crosses at 3, okay? So the axis of symmetry is the line at x equals 3. Now my vertex is the point right at that highest or lowest center point, depending on which direction the parabola is facing. Here it's the lowest point in the center. And remember, since the vertex is on the same x value as the axis of symmetry, these guys are always going to match. Okay? The x value of the vertex, your axis of symmetry, they're always going to have the same exact value because they're both right here at that x value of 3. And then the y value is a y value of negative 4. Okay, so there's your vertex at 3, negative 4. Now we've got our x-intercepts, and then we can talk about our solution. But remember, those are the same thing. So either way, we're talking about these points right here, where your graph crosses the x-axis. Okay? So whether we're going to call them x-intercepts or we're going to call them the solution, they are where x equals 1 and x equals 5. Okay? And that's the same thing for both. All right, name of this graph, it is a parabola. Now, the important thing here today, the really important thing I want you to take away, is that piece right there. When we're talking about solutions to a quadratic equation, it's going to be the two x-intercepts, okay? And notice there are two solutions. Okay? When we have an x-squared equation, we end up with two solutions. There's two places where that graph crosses x. So when we start talking about solutions now, you're going to have 2 points. Not 2 points. Well, yeah, they are 2 points. Excuse me. 2 points, and let's point that out. No pun intended there. That x value of 1 has a y value of 0. So it is a point. We can talk about it as x equals 1, or we can talk about the point 1, 0. Either way, it's right there. This one, we can talk about the point where x equals 5, the x-intercept, or we can talk about 5, 0, because that's where the y value is 0. And that's important to notice. Always with x-intercepts, that y value is 0. So anytime we talk about a solution, it's going to be those x-intercepts, and it's going to be where y equals 0. So those are saying the same thing. An x-intercept and where y equals 0 is the exact same thing. All right. Here is something new. This is something we're going to use with our quadratics. It's called the zero product property, and it's really cool. Okay, so can you hear all those kids in the background? Yep, hanging out with some family friends, and there's many kids running around right now. So if 2x equals 0, okay, think about that. If 2x equals 0 and you need to solve it for x, you can work it out. But you can maybe also reason it out right in your head. Okay? If I need to solve that for x, I would divide off the 2 on both sides. And then we have to remember and ask ourselves, what's 0 divided by 2? In other words, how much 2 can fit into 0? How many groups of 2 fit into 0? Hopefully, pretty easily, you come to the answer. Well, none. The answer is 0. Another way we can think about it, anything to get 0, what do we have to be multiplying by? If anything becomes 0, what do we have to be using as that value that they're multiplying with? It's got to be 0. 0 is the only thing that multiplies to equal 0. Let's try it again. If negative 5 equals 0, what does the x have to be? Hopefully, we're jumping to the exact same thing. X has to be 0 again, and that is what the zero product property tells us. It tells us anytime you're multiplying any number, if you get 0, it's got to be 0 you're multiplying by. Okay? 0 times anything equals 0. So now let's apply that here. If x times y equals 0, what do we know has to be true about either x or y? Or maybe even both. If we're multiplying two unknown things and they equal 0, what must be true of that x or else must be true of that y? Hopefully, you're jumping right to this. One of them has to equal 0. If x equals 0, then it makes sense, it works out. It doesn't matter what y is because that's now true. Or else y has to equal 0. So that x times that 0 equals 0. One of those things must be true, and that's called the zero product property. We're going to use that right now. All right. So we're going to bring together yesterday's lesson, introducing quadratics as graphs, and today talking about quadratics as their equations and starting to solve. All right? So if we're going to look at the equation over here on the left and the graph, wait, reverse that, huh? The equation we're going to work out over here on the right, and the graph is over here on the left. So again, where are our solutions? We're just going to focus on that, and they're right here. The solutions to that quadratic, when we graph it out, are x equals 1 and x equals 5. There's our two solutions. Okay? And remember, that's where y is 0 for both of those points. So this is, oh, now ungroup those guys. We're going to solve this quadratic, and we're going to see in a minute how it matches up with its graph. And this is the graph of the quadratic, okay? When you graph this quadratic, that's the parabola, that's the graph it makes. So we already know, if we do it correctly, what our solutions are going to be. We better come up with x equals 1 and x equals 5, or else we did something wrong. So let's try it and see what happens. Now, the first thing we need to remember is your solutions are when y equals 0. So we've got y equals. We actually have to have 0 here. So we're going to get rid of y, and we're going to say it's 0 instead. And we can touch on that more in a minute. Anytime you're supposed to solve a quadratic equation, you're allowed to replace the y with 0 if there's a y there. Okay? Sometimes there won't be a y there, and we'll deal with that later. Sometimes the y is already taken out of the equation. We'll deal with that in a minute. But if you see that y is there, you are allowed to replace it with 0, so that what we're doing now is we are solving this equation for x when y equals 0, which is exactly what we want. We want to know what x equals when y equals 0, because that's going to give us the two solutions to our quadratic. So it's basically letting us ignore the rest of the parabola. We don't care about any of the rest of this. If we're solving just to find the solution, we'll set the x to 0, and we'll get y to 0, and then we'll find our two values for x, which are the solutions. So we set it to 0, and now you use the skill you've already got. This is the factoring skill we just learned. Just use our trinomial, two magic numbers, factoring. What's going to add to -6 and multiply to 5, and we can see that it's a positive 5 multiplying, so we know that it's going to be two positives or two negatives. They both add to a -6. They must both be negatives, and so now we think, what are the only things that multiply to 5? 1 and 5 are the only things that multiply to 5, and if we check, they work out. They add to -6. So now we've got an x minus 1 and an x minus 5. Now notice, it equals 0. Don't forget that. That part's important. This equation equals 0, so bring that down. It should still equal 0. Okay, so now we have a factored trinomial. We've done what we already know how to do. And now it's equal to 0, so we can go a step further than we were going in the past. Before we would factor and we'd be done. But now, instead of just factoring, we can solve, okay? You only go from factoring to solving if your equation equals 0, okay? If we've set it equal to 0, now we can finish and solve it. So when you guys are asked to factor, you only have to go this far, you're done. If you're asked to solve, we're going to go one step further beyond this. Because it equals 0, we can find our actual solutions for x. Now, we just learned on the last page, if two values are multiplying and they equal 0, one of them must be 0. That's our zero product property. So remember, these two binomials, they're multiplying against each other. And even though it's something in parentheses, an x minus 1 and x minus 5, this whole quantity together is multiplying with this one. And somehow these two equal 0. If that's the case, then it must be true that either that x minus 1 equals 0, or it must be true that the x minus 5 equals 0. One of those two has to equal 0, because when they multiply and we FOIL them, we end up getting 0 in the end. So now we split them apart, we set each of them equal to 0, and we can solve it from there. And notice how simple it is to solve these after you did this. It's literally cancel and add over the 1, cancel and add over that 5, and now we have two solutions for that quadratic. We have x equals 1 and x equals 5. Does that sound familiar? There's x equals 1, and there's x equals 5. Okay, so we now have two ways to find solutions of a quadratic equation. We can graph the parabola and look for where it crosses the x-axis. Its two x-intercepts are the solutions. Or we can factor it, and if it's set equal to 0, we can also solve it, and we'll find the solutions that way. Okay, good news, there's nothing new for this lesson. We might even take the next lesson and just keep practicing. So let's just continue and practice and bring all that home, because I know there was just a lot we talked about. All right, here's the new equation. We got this x squared minus 5x plus 6, and right here is the graph of that equation. So if we wanted to look right now, we can already see the solutions, okay? And if those are really tiny on your screen, I'll just fill it in. Our solutions are x equals 2 and x equals 3, okay? So we know when we work this equation out and factor and solve it, we already know what we should see. Those should be our two solutions in a minute. So what do we need to do step by step? Number one, don't forget our equation has to be set to equal 0. Okay, that'll become more important on the next lesson. So first thing, this one that we're solving, it's got to equal 0. So now we've got it equal to 0. We've gone from an expression to an equation here. So make sure it's an equation. It's got something on both sides, and it's got to be 0 on the other side. Second, factor it. We already know how to do that. That's the easy part. Okay, just factor this guy. So we'll use the diamond. And at any point where you feel like you've got the idea of the diamond, you do not have to keep using it, but it's a great little graphic organizer to help keep you on track. And again here, since 6 is positive, we know they're going to be the same sign to multiply, and the answer is negative, so I know it must be two negative numbers I'm looking for, and they're going to add to 5. Probably pretty obvious already. The only choices are 1, 6, 2, 3, and if they both add to 5, it must be 2, 3. So now we'll rewrite it. It's going to be an x minus 2 and an x minus 3. And remember, it's equal to 0. So there's our second step. We set it equal to 0, and we solved it. Still equal to 0. We brought that 0 down. What's our last step? Solve it by setting each part, and those are technically binomials, equal to 0, which we just did on the last page. So since we've got that quantity in x minus 2 times that quantity in x minus 3, and they equal 0, it must be true that the x minus 2 equals 0, or the x minus 3 equals 0. One of those two has to be a 0 to make the whole thing cancel out, and then we just solve each of those two. So we've got x equals 2, and we've got x equals 3. Did we get it right? Let's take a look. And there we go. We solved it as a graph. We solved it as an equation that we factored. All right. I think it's time for a we try, don't you? All right, let's try it. So you guys see here, you've got your graph on the right, you've got your equation on the left. So if you know where to look, it's probably already obvious to you what the solutions are for this quadratic. We just need to be able to work that out with the equation and the factoring to see if you're correct and see if you can do it on your own. All right, I'll lead you and let you guys do the work and come behind you. So number one, step one, make sure you set your equation to 0. So do that right now. Okay, second, you need to factor that guy. Go ahead and factor him right now. And then remember, it stays equal to 0. When you rewrite it in factored form, it's still an equation equal to 0. Okay? I'm going to come behind you right now and do the factoring so that anybody who's stumped, I want them to be able to finish with us. And again, it's going to add to that -3, multiply to that -10. We know they're mixed signs because it's a -10. And the 10 could be 1 times 10, could be 2 times 5. Looks like a 2 and a 5. And it's a negative answer, so the bigger number, the 5, has to be the negative. There we go. So I'm going to have an x minus 5 and an x plus 2. And if you had the x plus 2 in the front, remember, it doesn't matter. All right, so there we go. We're factored. Hopefully you're there ahead of me. Now we're going to solve, and the way we solve is set each binomial equal to 0, and then just solve each of those. Go. Okay, should be doing that. There we go. And hopefully you got that ahead of me. Let's check and see. My solutions are x equals -2. Check, that's one of our solutions. And x equals 5. Check, there's our other solution. All right. All right, here's your homework for tonight. 3 trinomials. Go ahead and factor them and solve them. I didn't set them up with their graphs. Let's just practice our factoring and solving with these. I will go through and put the solutions to all 3 of these up at the end of the homework here. So you can go ahead and pause it now, work through them, and then you can unpause and see how you did. Go. Okay, I'm skipping steps here. I'm just going right to the solutions. That's what you should have got there. Those are kind of the bones, the bare bones of it. Okay, there you go. Remember, the step I left out on each of these is that you would set each pair equal to 0. Okay, that's how I'm getting to that solution. X plus 8 equals 0, and x minus 4 equals 0. Okay, and then you solve each of those equations. That's how you get to the solution, so don't forget that step. Those are your solutions. Peace out.